Hello everyone, welcome back to my channel, and in today's video we're going to continue developing the chess app which we started in the last video. In this video specifically, we're going to be concerned with spawning the chess pieces onto the screen, and in the next few videos we'll take a look at how we can move them about by taking user input. Without wasting any more time, let's get right into it. So this is where we last left off. But as you can see, I have imported these sprites into my Unity project. I found these with a quick Google search. They are open source and completely free to use. You're also free to use them in your projects. I did also find a lot of good 3D assets in the Unity asset store, and also a lot of good 2D ones. You're free to use them or any sprites you like. But for the purposes of these tutorial series, I'm going to continue using these. So before we get into getting these sprites to appear onto our game screen, there's one thing we need to do, and that is convert them into prefabs. Because Unity can only show these sprites when they are game objects. And to convert them into a game object, all we have to do is drag it over into the hierarchy. Now this bishop sprite has been successfully converted into a game object. As you can see, it has the transform component and the sprite renderer component attached to it, which are quite necessary, especially the transform component for the precise placement of each piece. And now to convert this into a prefab, first of all, I'm going to create a new folder just beneath our assets folder, and I'm going to name it prefabs. And then what I'm going to do is drag this bishop game object into the prefabs folder, and now it has successfully been converted into a prefab. You can see that the bishop game object has a blue cube next to it, which indicates that this is now a prefab. Now what we need to do is do the same thing for each individual sprite, and we do that by dragging these one by one onto the hierarchy window. And same for the bishop, the white king, the white knight, the white pawn, queen, and the rook. Now I've dragged these over to the hierarchy, and now I'm just going to select all of these and move them over to my prefabs folder. And now all of these game objects have been successfully converted into prefabs, and that is all the chess pieces, because these are all the chess pieces available in a chess game. And now we can get rid of these game objects, because we are going to access these prefabs from the board UI script that we have created in the last video. So before we open up that script, I want you to go to the scripts folder and create a new script, and I'm gonna name it piece utility. And this script is going to contain all the code for any logic or any fields which we might need relating to the chess pieces in the chess game. So if we just open this up in VS Code over here, this is the board UI script which we worked on in the last video. I have made a few minor tweaks and changes. Mainly, I have separated all the functions into their own separate regions to keep the code nice and neat and tidy. So there's a separate section for the awake function, which is a Unity function, and that is why it is in the region for Unity functions, and the same with private functions and public functions. So before we start coding and dive into the board UI script, first of all, I want you to open up the piece utility script and get rid of all these lines of code. This is going to be a static class. A static class is just a class which can be universally accessed by all other classes. So this is going to be a public static class piece utility, and a static class cannot inherit from mono behavior, which is a Unity class. So, and we don't need mono behavior anyways, so we are just going to get rid of it. And the same with these two functions over here. So first of all, we need an easy and quick way to access each piece by a numerical value, because it is easier to work with numbers when we are coding. And some of you who are used to coding might be thinking of enums or enumerations, and that is the logic we are going to use. But instead of creating an enum, I'm just going to declare integers, and these are going to be static integers because this is a static class. So first of all, I'm going to declare a public static int, and I'm gonna name it as a pawn. So this is going to be all the chess pieces, and each chess piece is going to be assigned a value. So a pawn which is equal to 1, and let me just copy this line and paste it over for all the chess pieces. So pawn, knight, bishop, rook, queen, and king. So this is an extra line of code, but we also need two references for the two colors in a chess game, that namely black and white. So this is going to be white and one more for black. So that is all for the piece utility class. It is going to have a little bit more code later on in later videos down the line, but for now this is sufficient. And now we just have to assign a value to each of these chess pieces and the two respective colors. So a pawn is 1, a knight is 2, a bishop is 3, and a rook is not going to be 4, it's going to be 5 instead. And I will explain this later on, but for now I just want you to bear with it and use the numbering convention that I have in this video. You can use a different convention later on when you understand why I'm skipping over the number 4, but for now just stick with this and you can make changes later on. Same thing goes for the two colors. White, I'm not gonna give it a number as 0 or 1. I'm gonna give it a value of 8, and the color black, I'm going to give it a value of 16. So those who have worked with bitwise operations or bitwise operators in something like Python or Unity itself might know where I'm going with these numbering conventions. But for the rest of you, again, just keep calm, bear with it for now. I will explain it later on in the later videos. So that is all for the piece utility class. Now we can go back to the board UI class and we can get started right away. So in the last video we accessed the two materials we created for the different squares by calling this serialized field. We are going to do the same thing for the prefabs we have just created in the Unity editor, and we can go ahead and do it right now. Serialized field, this is going to be a private game object, and it's going to be an array of game objects because there are going to be multiple pieces, and I'm going to call it pieces. Next thing we need a 2D array of sprite renderers, just like we needed a 2D array of mesh renderers to store all the squares of the chessboard. We need a 2D array of sprite renderers to store all the different sprites or the prefabs we just created at the appropriate location in the array. So this is going to be a private sprite renderer, and this is going to be a 2D array of sprite renderers, and I'm going to call it sprites. So, and don't forget to initialize the array we just created like I did in the last video. So this is going to be a 2D array of size square count comma square count, and square count again has the value of 8 because the chessboard is of 64 squares. So this is a 8 by 8 2D array. Okay, so how are we going to actually spawn the pieces onto the screen? So if you remember last time, we had two functions, a generate board function and a generate square function. The generate board function calls the generate square function one by one n number of times to generate the 64 squares of a chessboard. We're going to use a similar logic by having a spawn piece function, which is going to spawn one piece at a time, and a spawn all pieces function, which is going to call the spawn piece function one at a time for all the pieces available to us when playing chess. So let's go ahead and make these functions right now. So I'm going to declare first the spawn pieces function, which is going to be responsible for spawning all the pieces in our game, and this is going to be of type void because it doesn't return anything. But the spawn piece function, which is going to spawn an individual piece, needs to return a sprite renderer because that is what our 2D array is, our array of sprite renderers. So it is going to return a sprite renderer, and this function is going to be called spawn piece, and this function is going to take in as input one, the type of piece it has to spawn. So it can be either a rook, a knight, a pawn, a king, a queen, whatsoever. and the color of the piece. So it can be either white or black. And this in turn relates to the enums we have just created in our piece utility class. So you can see how these are going to be useful now. So this is going to be an int of the type of piece and one more int for the color. So these are the two parameters this function is going to need. So first of all, we need a way to relate the index of the piece in the pieces array and the value associated with each piece declared in the piece utility class. So that is going to happen by a formula I'm just going to write down right now, and I'll break it down once it's there. So this is going to be int type int. I'm going to call it index because it is the index of the piece, and this is going to be type -1 plus color equal to 8, 0 or 7. Okay, so for this to make sense, let me just write down the entire function, the spawn piece function, and then I'll explain why this makes sense and why this will work. So we're just going to assume that this works for now, and then I'll explain it one at a time. So now we have the index of the piece. Now we just need to actually instantiate the piece onto our screen. Now Unity gives us an inbuilt function for this, the instantiate function, which can spawn prefabs or game objects onto the screen, which are in our assets or project folder. So we need a reference first to the sprite, and this is a sprite renderer. I'm just gonna call it sprite, and this is going to be instantiate the pieces array, and we want the piece at location index. And because this is a sprite renderer, not a game object, but the pieces array is a game objects array, we need to do get component sprite renderer, and that is it. So this will make sense once we actually add the pieces. So this is giving us an error. So that is just because we haven't returned the sprite renderer variable, and now all the errors should be fixed. So hopefully everything except this line of code should make sense to you. This line I will explain later on. For now, we are more concerned with the spawn pieces array. So for the purposes of this video, this spawn pieces function is going to look a little bit messy. It's not going to be neat and tidy because we actually don't have a good logic rather, to spawn all the pieces one at a time through a single line of code. That we will get when we access a concept called as fence strings, a standard notation in the chess world. But that's a topic for another video, maybe the next one or the one after that. So we're going to spawn a piece one at a time. Let's talk about the bottom left piece in the chessboard, the white rook. The white rook has the location 0, 0 in the sprites array. So sprites of 0, 0. And to actually spawn the piece, we just have to call the spawn piece function and pass in piece utility dot rook, and the color is going to be white. So piece utility dot white. Oh, my bad, that's a typo. White. Okay, so that should spawn the white rook for us. Let me just get rid of these parentheses over here. Yeah, that should spawn the white rook for us. And similarly, we have to do the same thing for all the other pieces in the for the white player. So the next is going to be the white knight, the bishop, the queen, the king, the white bishop again, the white knight, and the white rook. So this is going to be 1, 2, 3, 4, 5, 6, and 7. And we just need to make sure that we make the specific changes to the pieces. So the knight, the bishop, the queen, the king, the bishop again, and the king's knight. Okay, So that is all. That is it for all the pieces on the back rank of the white player. Now for the pawns, we can all the second row, the second rank rather, if we use chess terminology, the second rank entirely is going to be filled up with pawns. So we can just create a simple for loop and just call the sprites spawn piece function for uh, I comma the first rank, not rather the second rank, because indexing starts from 0 encoding. What a surprise. And we just call the spawn piece function for piece utility dot pawn, and the color is going to be white. So that is it for the logic for all the white pieces. Now we just have to replicate this code for all the black pieces. So this can be just like this, and instead of 0 over here, this is going to be 7, because that is the last value, and this is going to be 6 instead of 7, because 7 minus 1 is 6. And we just have to make sure that we change the color so that there is an easier way to do this. White, black, and that is it. So that is going to be the code for the spawn pieces function and the spawn piece function. Now we just have to call the spawn pieces function inside of our generate board function, and we can do this just beneath the two nested for loops. We can just say spawn pieces, and that should take care of spawning all the pieces. Now if we go back to the Unity editor and wait for it to compile all the C# scripts. Okay, now we just have to make sure that we attach the pieces in our inspector window to the board UI script, just like we did for the two materials of the square colors. And now here's the important part. We have to make sure that the element number over here corresponds to the value given to each piece in our piece utility class -1, because let's say if we're talking about the rook has a value of 0, and this is where I said I would explain this line of code over here for the indexing of the pieces. So let's say the white rook has a value of 5. So the index should be 5 minus 1, and since the color is white, that is color equal to 8, which corresponds to the white color over here. If it is equal to 8, then the value of index will be 5 minus 1, that is 4. So we have to make sure that the white rook ends up on element number 4. So if we go to our prefabs folder and just make sure that a white rook is over here, and the rest of the pieces should be in the correct order. So a pawn followed by a knight followed by a bishop. Then the third element has to be empty because we left the value 4 not assigned to any piece, followed by the queen, the king, and the same thing goes for all the black pieces. So the black pawn, the black knight, the black bishop, the black rook, again leave one space empty, the black queen, and the black king. Now that we have attached all these prefabs to our board UI script, we can try and run the code, and hopefully it should work. But it does work, but there are a few discrepancies which we have to address. One, they're all at the center of the board. That means that they are not positioned correctly. Two, each piece seems a little bit enlarged for as compared to the size of the chessboard or the size of each individual square. So we have to address that. And one more minor discrepancy, which might not matter to everyone, but it matters to me, is that the pieces are being generated, but they're not a child of the chessboard game object like the squares are. So three things we have to take care of: the position of the pieces, the size of the pieces, and the parenting issue. Just like some of you out there watching this video, but whatever. So how can we do that? Well, it's quite easy. We have to create two functions, one for the positioning of the pieces and one to resize all the pieces. So let's get started with that. So the position piece function is going to take care of the placement of all the pieces. It's going to take in as input the file and the rank of each piece we have to position, and the same thing goes for the resize piece function. I'm just going to call it, instead of position piece, resize piece. So it is also going to take in as input the file and rank, that is the parameters of these functions. So to the position the piece, we just have to access the piece from the sprites array by its file and rank. And how are we going to actually position these pieces? So if we think about it intuitively, the center of the piece should coincide with the center of the square it is supposed to be on. And how do we get access the center of the square? Well, we already have a function for that, which we created in the last video, which is over here, the get square center function. So if we just call the get square center function for the specific file and rank, that should take care of all the positioning for okay. So we're not supposed to actually assign the value. We are supposed to do transform dot position and assign the value of get square center to this. So that is the position piece function. For the resize piece function, I actually want to have a reference to the piece. So I'm just going to declare a new variable sprite, and I'm going to store the piece in the sprites array, just like this, because we're actually going to be using this sprite variable twice in the function. So instead of writing the code again and again, it's better to just store it in a variable and access the variable. So how much do we want to actually scale the pieces by? Well, it's quite easy if we think about it. We already have the size of a square and we have the size of the sprite. So if we just take a ratio of the size of the square by the size of the piece, and we assign it to the local scale, which is a property that Unity gives us for sprite renderers, then our work is done. So I'm just going to create a new float. I'm going to call it scale factor, just because it is how much we want to scale the piece by, and that is just going to be a ratio of the square size divided by the size of the sprite. Now the sprite is bounded in a square box, so it doesn't matter if we use the width or the height, they both have the same value. And to access this value, Unity gives us sprites.bounds.size, and we can do that in either the x or the y direction, it doesn't really matter. And then we can just do sprite.transform.local scale, and we have vector 3.0, because it does have to be a vector 3.0, and we are going to times it by the scale factor, and that should scale these two sprites. Now, how do we actually call these functions though? If we just call them blindly beneath the spawn pieces function, then it won't actually work, because the generate board function is only called once, and then it will only call the position piece and resize piece function once. But if we iterate through the entire array and call them one at a time, then what happens if at X location the array is empty? Then Unity will give us an error. So we have to implement a small check to make sure that the array at the given position or at the given index isn't empty. And if it is not empty, it is occupied by a piece, then we call these two functions. So for that, we need these two nested for loops again beneath the spawn piece function, and inside them we check if sprites of the given file and rank is not null. Null is just a keyword in C# to check if it's empty or not. And if it is not empty, then we call the position piece function for the file and rank, as well as the resize piece function for that file and rank. So that should take care of the placement of the pieces on the screen, as well as the size of the pieces on the screen. Now there was one more issue we had to address, and that was the parenting. We have to make the pieces children of the chessboard game object, and we can do that over here in the spawn piece function. We can just say sprite dot transform dot parent equal to the transform component of the chessboard game object, which this script is attached to. So we can directly call the transform parameter like this. So now if we go back to the Unity editor, we'll just wait till it finishes compiling the scripts. And now if we run the code, uh, it isn't spawning the pieces. Okay, it is spawning the pieces, but I don't think okay, they are at the proper location if as we can see from over here, but they aren't actually appearing on the screen. There are no errors either. So I think we have a little bug which we need to address. And okay, let's get rid of this line and then try to figure something out. So if we run this code now, okay, the pieces are still not appearing. So the problem wasn't with this line. Let's just check. Is not equal to null position piece file rank resize piece file rank. Okay. It's not supposed to be vector3.0 because 0 times any value is going to be 0. So the pieces are actually there, but they are scaled to a size of 0. So that doesn't make sense. So it should be vector3.1. And now if we run the code, everything should be in place. So yeah, the pieces are in the proper place, they're of the proper size, and they are children of the chessboard game object, just like we wanted. So that is going to be it for this video. In the next video, we'll take a look at how we can move these pieces around on our chessboard. It might be a long video, I haven't figured it out yet, but stay tuned for the next video, guys, and I'll see you guys next time. Peace.